All right, let's dive into this paper that kind of set the AI world on fire. Generative Adversarial Nets. If you're a programmer, and even if AI isn't like your bread and butter, this is going to be your decoder ring for one of the core concepts that's, well, it's everywhere now.
Yeah,
And we've got our expert here to help us break it all down, ready to jump in.
absolutely. Let's do it.
So this paper, it introduces this thing called a GAN, right? A Generative Adversarial Network. It's this system where two AI algorithms basically go head to head, almost like like a game.
Yeah, it's all about that adversarial thing. You got it. So we got the generator, which is trying to, well, create data. It could be images, music, anything really. And then on the other side, you've got the discriminator. Its job is to figure out, is this data real or is it fake? Like, did the generator make it?
So is it kind of like, I don't know, a counterfeiter trying to pass off fake paintings?
Mhm.
And then you've got like an art expert who's trying to spot the forgeries?
Exactly, you nailed it. And the really important part here is that both of these, the generator and the discriminator, they're neural networks. They learn from data and, they get better over time.
Ah, neural networks. Those things that are like kind of based on how our brains work with the whole pattern recognition thing.
Yeah, but instead of neurons, we're talking about like artificial nodes and connections processing information. So as these networks go through training, the generator gets better at making the fakes, and the discriminator gets better at spotting them. So it's this constant back and forth.
Okay, I think I'm starting to get it, but can you give us like a concrete example of how this actually plays out?
Sure. So imagine you're training a GAN to generate images of cats, right? The generator, it starts with random noise, just a jumble of pixels, and it tries to turn that noise into a believable image of a cat. Now, the discriminator, it's looking at both real cat images and the ones the generator's making, and it's trying to tell them apart.
So both of them are learning, right? The generator's figuring out from the discriminator's feedback what makes a cat image look convincing.
Exactly. And the discriminator is becoming more discerning, picking up on those subtle details that separate the real cats from the generated ones. And what makes this paper so groundbreaking is, well, it doesn't just lay out this architecture, it actually proves mathematically that the ideal outcome is a generator that can perfectly replicate the data it's trained on.
Hold on, perfectly replicate. So you're saying it can create cat images that are indistinguishable from like a real photo.
That's the theoretical endpoint, yeah.
Yeah.
The paper uses game theory, specifically this idea of a minimax game, to kind of model this whole adversarial training process.
Game theory. That sounds a little intimidating, to be honest.
Well, to put it simply, a mini-max game is one where you've got one player who's trying to like maximize their gains, and the other player is trying to minimize their losses. So in the case of GANs, the discriminator wants to be as good as possible at telling real from fake, and the generator wants to, well, minimize how well the discriminator can do that.
So it's like they're locked in this constant battle, but it's that battle that makes them both better.
Exactly. And the paper goes into some pretty complex math to show that under the right conditions, this mini-max game leads to a point where the generator's output is basically identical to the real data.
Wow. Okay, that's pretty wild. So how did they actually demonstrate this, in a practical way?
They did experiments on a few different data sets, handwritten digits, faces, and just more general objects. And the fascinating thing is, even with these early GANs, the images they generated were surprisingly realistic. It was proof that this adversarial training approach, it could actually work.
Okay, I'm definitely seeing how powerful this is, but for someone who's just wrapping their head around this, what would you say is the key takeaway?
I'd say the main takeaway is that GANs offer a fundamentally new way to train generative models in AI. By putting these two networks against each other, we can create systems that learn to generate realistic data. And we don't have to rely on like complex handcrafted rules.
So instead of telling the AI exactly how to create, say, a cat image, we're letting it figure it out on its own through this adversarial process.
Exactly. And that's just scratching the surface of what GANs can do. But even though it's a really powerful idea, the paper doesn't shy away from some of the challenges with GANs.
Yeah, because training these things, it can't be like a walk in the park, right?
Not exactly. One of the big ones is that this adversarial training, it can be a bit unstable. Imagine the generator and discriminator like adds two dancers trying to stay in sync. If one of them gets too far ahead of the other, the whole routine falls apart.
So it's all about finding that balance where they're pushing each other, but not like completely throwing each other off.
Precisely. And there's no, guaranteed recipe for getting that balance right. It often takes a lot of experimentation and fine-tuning.
Makes sense. So what are some other limitations they talk about in the paper?
Well, another one is that with these original GANs, there's no easy way to directly measure how well the generator is capturing the true distribution of the data. We can kind of judge it by looking at the images it creates, but that's pretty subjective, right? It's like saying, this fake cat looks pretty real to me, but you don't have a precise way to quantify that realness.
So it makes it tough to, like, objectively compare different GANs or even just track their progress.
Exactly. Although it's worth pointing out that a lot of the research since this paper came out has been focused on tackling these limitations. There's a whole family of GAN architectures now, each with its own, strengths and weaknesses, but those are deep dives for another time.
Definitely something to explore further down the line. But before we get too far into the weeds, let's bring it back to our programmer who's listening. Why should they care about GANs? How could this technology, you know, actually impact their work?
Well, think about all the time and effort that goes into gathering and cleaning data for software development, right? What if you could just generate synthetic data instead? Like, let's say you're building a facial recognition system. Instead of collecting thousands of real faces, which, can come with privacy concerns, you could train a GAN to create a whole data set of synthetic faces. You could have different ages, ethnicities, lighting conditions, the whole works.
So it's like having a virtual photo studio at your fingertips.
Exactly. And it's not just images either. Researchers are even looking at ways to use GANs for generating code. Imagine automating parts of the programming process itself, generating code snippets, or even entire programs based on specific requirements.
Wow, that's pretty mind-blowing. So instead of writing every line of code from scratch, a
Yeah.
programmer could have a GAN assist them, potentially speeding up development and, freeing up time for the more complex stuff.
Precisely. And those are just a couple of examples. The potential applications of GANs in programming are huge, and they're constantly expanding. What's exciting is that we're really still in the early stages of figuring out what's possible with this technology.
It's like we've opened this door to a whole new world of possibilities.
Absolutely. And one of the things that I find so fascinating about GANs is that they represent a real paradigm shift in how we think about AI. Instead of programming machines with explicit rules, we're now enabling them to learn through this adversarial process, almost like they're, playing a game.
It's like we're giving machines a bit of creative freedom, letting them figure things out on their own.
In a way, yeah. And that's incredibly exciting. It opens up the possibility of machines coming up with solutions and ideas that, we humans might never have thought of.
It's both thrilling and a little bit unsettling at the same time, isn't it? This idea of machines becoming more creative, more autonomous.
It certainly is. And that's why it's so important for us to keep exploring these technologies responsibly, thinking about the potential ethical implications as we go. But that's a discussion for another time.
Indeed. This deep dive has given us a lot to think about. We've covered the basics of GANs, their strengths, their limitations. We even touched upon some of the broader philosophical implications. But before we wrap things up, I'd love to get your final thoughts on the significance of this paper and what it means for the future of AI.
Well, this paper, there's no doubt about it, it marked a real turning point in AI research. It introduced a powerful and versatile tool that's had a profound impact on so many fields. And its influence, it just keeps growing.
It's amazing to think that this one paper, published just a few years ago,
Mhm.
has already sparked so much innovation. Where do you see this technology heading in the next few years?
Well, I think GANs are going to continue to play a really central role in shaping the future of AI, from creating more realistic and immersive virtual worlds to, really pushing the boundaries of what machines can create and imagine. We're already seeing GANs being used in areas like drug discovery, medical imaging, even art and music generation.
It's incredible to think about the potential impact on so many different fields. And for our programmer who's listening, what's the one thing you hope they take away from this deep dive?
I hope they come away with a sense of the power and potential of GANs. This is a technology that's becoming more and more accessible all the time, and there are countless opportunities for programmers to experiment with it, to apply it to their own projects, and to, really push the boundaries of what's possible.
That's a great message to end on. It's an exciting time to be in the world of technology, and it's clear that GANs are going to play a major role in shaping the future. But before we say goodbye, I want to thank you for joining us on this deep dive. Your expertise has been invaluable in demystifying this complex topic.
Yeah, it's been my pleasure. I always enjoy diving deep into these fascinating subjects. And to our listener out there, thanks for joining us on this deep dive. We hope you've learned something new and exciting today. But the learning doesn't have to stop here. the paper we discussed, Generative Adversarial Nets. It's really just the tip of the iceberg. There's a whole universe of resources out there if you're interested in exploring the world of GANs further. Tutorials, articles, open source code, you name it.
And don't be afraid to get your hands dirty, experiment a little. The beauty of programming is that you can take these concepts and actually apply them to your own projects, create your own GANs, and see what amazing things you can generate.
Yeah, absolutely. That's a great point. This technology is becoming so much more accessible. Who knows? Maybe you'll be the one to come up with the next big breakthrough with GANs.
I wouldn't be surprised. There's so much potential still out there, just waiting to be, unlocked. It's an exciting time to be in the world of AI, and we can't wait to see what the future holds. Thanks for joining us on this deep dive into generative adversarial networks.
Thanks for having me.
And to our listener, thanks for diving in with us. Until next time, keep learning, keep exploring, and keep pushing the boundaries of what's possible